Numerical integration. Numerical integration is the process of evaluating a definite integral from a set of tabulated values of integrand f of x. Definite integral means replica of area under a curve within a certain limit. In order to calculate such area, there have been developed a number of analytical methods, but they are time consuming or chance of error is very high. That is why techniques of numerical integration methods are much popular in calculation. There are two methods of numerical integration. They are trapezoidal rule and Simpson's rule. In this PPT, we will learn about trapezoidal rule. Trapezoidal rule. Under this rule, the area under a curve is evaluated by dividing the total area into little trapezoids, as we can see from the figure. Let f of x is continuous on closed interval ab. We partition the interval a to b into n intervals, each of which h equal to b minus a divided by n, such that x0 less than x2 less than x3 less than etc. to xn. The trapezoidal rule for approximating integral a to b f of x dx is given by h by 2 into y0 plus yn plus 2 into y1 plus y2 plus etc. like that plus yn minus 1.
Here we discuss a numerical integration problem solved by using trapezoidal rule numerically. The question is evaluate integral 0 to 6 1 by 1 plus x square dx using trapezoidal rule. Here y is a function of x, y equal to 1 by 1 plus x square. As seen on the table, it is divided into 6 equal parts and find values of y in terms of x. After we finding the width between each value of x, that is h equal to 6 minus 0 divided by 6 equal to 1. Then we done the numerical integration problem using trapezoidal rule. Hence we substitute the values of y in trapezoidal rule formula, that is h by 2 into y0 plus yn plus 2 into y1 plus y2 plus etc. plus yn minus 1. Here y0 is the value of y at x equal to 0 and y1 is equal to values of y at x equal to 1. Similarly, y6 equal to values of y at x equal to 6, and substitute the values in equation, that is 1 by 2 into 1 plus 0.027 plus 2 into 0.5 plus 0.2 plus 0.1 plus 0.0588 plus 0.0384 and get the answer.
Now let us discuss about the algorithm of trapezoidal rule. First, start the program. Then define the variables and data types. Next, the floating values sum1 and sum2 are initialized to 0. Now we can input n and h, where n is the number of subintervals and h is the step size. Creating an array and storing the value using for loop is the next step. For convenience, we split the trapezoidal rule into two parts, sum1 and sum2, where sum1 is calculated using equation sum1 is equal to h into initial value plus final value divided by 2, and sum2 is calculating by this equation sum2 is equal to sum2 plus h into intermediate value. We need to input the required position as in the problem. Finally, we declare the result, that is the final value with required position, and last we stop the program.
Let's see how trapezoidal rule can be applied using a C++ program. In the main function, first we declare the variables and the data types required. Two integers n and p and floating values h, sum1 and sum2 have been declared, where sum1 and sum2 are initialized to 0. Let us understand this program by using an example. In line 7 and 8, we have to enter the number of intervals. It is stored in n. In this example, the number of intervals is 4. Therefore, 4 will be stored in n. In line 9 and 10, we have to input the interval width h. In this case, the interval width is 0.25. Therefore, 0.25 will be stored in h. In line 12 to 15, we are prompted to enter the f of x values. As we know, if there are n intervals, there will be n plus 1 f of x values. A for loop is used to input the f of x values. In line number 16 to 17, we have to enter the precision p. Let's say the precision is 4. For convenience, the equation of trapezoidal rule is split into two parts. Line 18 calculates sum1, which is the first part of the equation, that is n by 2 into sum of first and last values. Line 19 to 21 calculates the second part of the equation, that is sum2, which is the product of h and the sum of all the intermediate values. A for loop is used to get the sum of all the intermediate values. The command cout.precision p sets precision to 4. The output displays the required integral, i.e. sum of sum1 and sum2, which is rounded out to 4 decimal digits. Let's see how trapezoidal rule can be applied using a C++ program.